What's up everyone, Patrick here, welcome back. And in this next question, we have to find out what is the solution to these two inequalities here. So starting with number one, we got negative 3x, I'm going to rewrite it over here, minus 4 is greater than 8. And what you want to do is isolate for the variable. So personally, when I isolate for the variable, I like to try to make it in a way where I don't have to worry about flipping the inequality. So notice it's a negative here. We want to make it a positive. So I would bring it over to the right side, bring the 8 over. So we'd end up with negative 4 minus 8 is greater than positive 3x. So we'd have negative 12. And because we're dividing by a positive value, we don't have to worry about flipping that sign. So basically x would be less than negative 4. Now if you did it the other way, where you brought this over, you'd end up with 8 plus 4. So you'd end up with negative 3x is greater than 12. Then when you divide by negative 3, because you're dividing by a negative, you got to flip that sign. And you'd end up with the same thing, right? This and this are the same thing. X is less than negative 4. So that would be the solution. If you graphed it on a number line, let's say this is a number line at 0, all the x values less than negative 4. It's not inclusive of negative 4. So that would be an open dot right there. Right? If this was greater than or equal to, then you'd end up with x is less than or equal to negative 4, this would be a closed dot. But because it's just less than negative 4, it would be an open dot like that. Right? So that's the answer to number 1. Now with number 2, same sort of thing. There's just a lot more going on. What you want to do, you basically want to isolate for the variable. So you bring all of the terms that include the variable to one side, all of the other terms to the other side. And again, I like to try to do it where that term in front of the variable, that coefficient in front of the variable is going to be positive. So notice we have negative 2, 9, and 5. So if we bring the 5x over, notice we'd end up with a positive on the left side. And then negative 7 plus 41, and then the 10 would come over, it'd be a minus 10 like that. Okay, so what would end up happening here is we would end up having 2x, right? 9x minus 2x is 7x minus 5x is 2x, greater than or equal to, over here, we would end up having 41 minus 7 would give us 34, minus 10 would give us 24. Divide both sides by 2, x is greater than or equal to positive 12. That's what the solution is. Now, if you brought all the x values to the right side, all the numbers to the left side, what you would end up having is pretty much the opposite of this. So you'd end up with negative 24 is greater than or equal to negative 2x. Like that. But then when you divide by negative 2 over here, you got to flip this sign. So the sign would end up being like that, and you'd end up with positive 12. So x would be greater than or equal to positive 12, which is exactly what we got here. So whichever way you do it, that's the value. And then if you want to show that on a number line, with a number line, we always start with 0. All the x values greater than or equal to 12. So let's say 12 is over here. It's greater than or equal to 12, so that's a solid dot. And then we'd end up with this arrow like that. So it's basically all of these x values, including the 12. Over here is all these x values, but it wasn't including the negative 4.